Hey everyone, welcome back to another video. So this video is a bit different, right? I'm gonna be starting a new series that I always wanted to, and so and I will be doing a lot of videos on these, but this is the first video on this particular series. The series is gonna be about low level design, right? How do we structure our code better, how do we write our code better, and how do we design our code, the reason that I'm making this is because I I learn these things during my work, right? And I try to apply them. So I thought, and I really like how you know how how things are written and how you apply these things in your day-to-day code, right? It's just the way of thinking about the right pattern, about the right decision, right? It's very interesting. So that is the reason I thought I would make a series on it, and I would give whatever I learned about these things. Okay. So yeah, with that, let's get started. So if you guys don't know what a design pattern is, in a layman term, it is nothing but a better way to design your code, right? There are a lot of ways you can write a code, right? There are a lot of ways. You can write your entire code base can be functional, right? Instead of object oriented, right? You took a decision of it being object oriented for a reason. The reason can be anything. It can be scalability. It can be readability. It can be, to handle complex data, right? But you took a decision to go with an object-oriented design. Right? Under object-oriented design, uh, you can write the code in your way, right? But the most challenging part, the easiest part is just to write the code, right? Anyone can do that, right? But the most challenging part is to how do you write the best code? How do you design the best code, right? And the decisions that you make on that is what that actually matters, right? So with that said, design pattern is nothing but it is a better way to design and write your code, right? It is just a pattern, right? It does not provide any functional changes, right? It's just a way to structure your code better, to make it more scalable, to make it more readable, right? So it is just a way to structure your code better. So in a layman term, that is what a design pattern is, right? You have a lot of design patterns, right? We'll be going through all of them, right? But yeah, so now you've understood what a design pattern is. Let's see what kinds of design patterns we have. So we have three main design patterns. One is creational, right? One is structural, and one is behavioral. So creational design pattern talks about what are the best patterns that we can use while creating an object, while creating an instance of a class. And structural design pattern tells you how we can structure our code better, and behavioral tells you like how, like when how an object is supposed to behave, or how a code is supposed to behave, and how we can structure it better, right? These are very layman terms, right? I'm saying this because I'm just starting it out. So let's just go with that. Eventually you will get a clearer idea on what it is. Now, what are the prerequisites of this? Prerequisites of this, before you start design pattern, I would suggest that you at least need to know what is object oriented programming, right? You need to know what are classes, right? What are constructors? What is a constructor chaining, right? What is inheritance? How do you inherit a class, right? What are the different types of you know what are the different type what is encapsulation, right? What is private classes, private methods, private attributes, what is public, what is protected, right? Or what is default, what is an interface, what is a abstract class, what is a static method, right? What is an instance method, what is a class method, what is method overriding, method overloading, runtime overriding, runtime overloading. All these concepts come under oops, right? All these concepts come under oops, right? And for you to start with this course, start with this particular series, you need to exactly understand what are these, right? When you understand these pattern would start making sense to you, right? If you don't even know what a class is, right? Why do you define a class? What is a constructor, right? Why do we need constructor chaining? What is constructor chaining? What is inheritance? If you don't even know this, right, it doesn't even make sense for you to come here and learn about design patterns, right? So I would suggest that you learn this first, right? And then you come to the design patterns. Okay, so this series is gonna start out with the assumption that you know this. Okay, okay, perfect. Now let's get started. So what are we gonna do? First, we're gonna focus on creational design patterns. So under creational, you have a lot of design patterns. Like under creational, you have singleton, you have factory, you have builder, you have abstract factory, and I think you have few two other things. I'm not sure, but these are the things that uh, that we have under creational design pattern. Right now, what is a creational design pattern? Creation design pattern is nothing but it tells you how an object has to be created. Like what is the best way to create an object of a class, an instance of a class, right? This is in a layman term, right? This is what a creational design pattern talks about. So under creational, today we're going to talk about singleton design pattern, right? So the pattern that we're going to focus on is singleton. Okay, perfect. Now let's get started. Okay, what is singleton? This is very interesting because for the people who know singleton, it's just not about singleton, right? It's just not about using the pattern. It's not that. There is so many things behind it that you also need to consider, right? That we'll talk about today. Okay, so let's get started. What is singleton? Let's take an example. So the resource that I'm referring is a website called Refactoring Guru, right? I can show it to you, right? This is the website, right? You can refer this. It's open source, right? This is the one that I'm referring, right? And I will be taking few examples. I'll be taking it from here. If I find better examples, I'll be taking that, right? Okay. Now, let's say that let's say that you have a system, right? You have a system. This is your system, and this is your database, right? In your system, you have multiple files, right? Multiple folders, multiple files, right? Each of them are talking to the DB, right? Each of them are making contact with the DB. Okay, now what does the DB provide? It provides initializing the connection. Let's say it provides methods like initialize connection, right? Establish connection, initialize connection, uh, term let's say terminate connection, and what else? Initialize, terminate, uh, fetch data, uh, fetch data, things like that. Let's say these are the common method that your DB provides. Okay, now let's say that we have a class, right? Called as we have a class called as database connection. Right? We have a class called database connection. Right? Inside this, you have a constructor called database connection. Database connection. Okay. Now, this is your class, and this is your constructor. Right? What are you doing in your constructor? Nothing for now. Let's just leave it like that. Right? And these are the methods that your let me remove fetch data. Let's just say that we have these two methods. Right? These two methods are there in your class. Okay. Now you have other classes, right? You have class A, right? And then you have class B. Let's just take two classes for now. You have class A and class B. Okay. Now, like I told you, a lot of systems are trying to establish a connection with your DB. Right. Now, ideally, if you want to access this particular class, what do? You will create an object of this class, right? Ideally, you will say database connection, obj1 equals to new db connection. I'll just call it as dbc, database connection. Okay, perfect. Right? Now, see, the thing is, okay, let me go to that. Okay, now over here, what you do is, okay, wait. When you do database connection, ideally, let's say that assume that you will establish the connection. Okay, now in this particular class as well, you will initialize the connection again. This is obj. Let's call it obj1. Okay. Now, tell me something. You have a system, right? You're having a system, right? In the same system, you're establishing the connection with database again and again. It is the same database, right? It is ideally the same connection, right? From your system, but from your system, you're establishing the connection again and again, right? Right? In this class, you're establishing it once. In this class, you're establishing it once. It's the same database, okay? But you're doing it twice. Is there a need of it? Right? These are just examples of two classes, right? There can be plenty more classes which are establishing this connection with database by creating an object of it. Okay? Is there a need of it? It is the same database. All you have to do is establish the connection once. Right? All you'll have to do is establish the connection once, and once you establish the connection, you can use that connection across all these classes. Right? So you don't need to do it many times. Right? So that is what your singleton is. What singleton tells you that, hey, if you have an class, right, which need not be instantiated more than once, right, you don't have to instantiate it more than once in, like, across other classes, right? Not only classes, across anywhere, right? So that is what singleton tells you. Okay, now tell me something. Can we stop anyone from doing this? Right? Can we stop anyone from doing this? No. Why not? Because they can do it, right? I mean, if I want another object, all I'll do is I'll copy this, right? I'll just make this obj2, right? There is literally no issue, right? I cannot stop anyone from doing this, right? So I need to figure out a way. Okay, if I cannot stop anyone from doing this, there may be chances that more than one instance of that class is being created, right? Now we need to make sure that only one instance of the class is created. How do we do it? Okay, let's think about it. Okay, let's think about it. Now, how do you create an instance of a class? Right? you give this new keyword, you ideally give this new keyword, right? You ideally give this new keyword, and then you call the constructor over here. Okay, so with this you're saying that I want a new instance of this particular class. Okay, so you call the new keyword, then you call the constructor, right? Since you're able to call the constructor, by default this constructor is public, right? Since you're able to call this constructor, you're able to create as many as objects that you want. Okay, now solution, what do we do? I will make this constructor private, right? I will make this constructor private. Now, when I make this constructor private, can I access it from outside the class, outside from here, or from here? Can I do that? This will throw you an error, right? Now new DVC will throw you an error. New DVC will throw you an error, right? I cannot access this from outside the class, right? Perfect. Now you can ask me, hey Siddharth, you have done this. That's okay. Now, if you have done this, how do I even create an instance of this object? Right? How do I even create an instance of this object? Right? Now, what we're going to do is the control for creating an instance, for creating an instance of this class, right? The control for creating an instance of this class, we're going to give it to this class itself. Right? The control of creating it will be under this class itself. This is going to take care of creating the instance. It's not going to let anyone else control the creation of instance of this class. Right? This is a very important point. Let me repeat it again. What I'm saying is that the control for creating an instance of this class is in this class itself, right? It is not given to these classes. Okay, now since we have the control, we can control on how many instances are being created, right? How many instances are being created, right? Perfect. So what I'm going to do is this is let's say that this is solution 1 that we are talking about. This is heading towards our final solution. Okay, now solution 2, it's in a sequence. Okay, solution 2. Now what we're going to do, let me copy this Singleton. Now what are we going to do? Let's go to solution 2. Now let's go back to the question that you had asked me. Siddharth, you had made it private. How do I create an object? Right. For that, what did I say? The control of creating an instance of this particular class is gonna lie in this class itself. Right. So what am I gonna do? Right. Now let's forget about these methods. Right. It's not in the scope. Right. Now, what are we gonna do? Right. Now, what are we gonna do? I am going to create a method. Right. This method is going to be called as get. This method is going to be public. This method is going to be get instance. Right. Get instance. What this method is going to do? This method is going to provide you the instance of this class. This method is going to provide you the instance of this class, right? So any class outside would have to call this method, right? Would have to call this method get instance to get an instance of this class. Perfect. Now, again, if you think closely, you might have another question, right? Hey Siddharth, you are defining this method, you're defining this get instance method under the database connection class, right? But don't we need an object of this class to call this method? Right? obviously, right? Because this class is under this, I mean this method is under this class, right? So obviously you need an object of this class to even call this method, right? So now what are we going to do? This is where static comes in. What is static? Static gives you a instance sorry, it gives you a class method, right? So you don't have to create an object to call this method, right? If we declare this static, if we declare this static, right, we can directly call database connection dot get instance, right? We can directly call this. Perfect. Now okay, now you got to know how we can call this, right? Now that we have defined a method called get instance, right, now the control is in our hands. The control is in our hands now, right, to create how many ever instances that we want, right? Because what is happening, get instance is a one which is creating the instance, right? Now get instance can create how many ever instance it wants, or it can create only one instance if it wants, right? So the control has come under get instance, right? Now according to Singleton, what we're going to do, we're going to create only one instance, right? That logic is pretty simple. All you're going to do is, you know, we can probably have you know, a static method, right? We can have a static method, sorry, a static attribute, a static private attribute attr, and call it instance. Oh sorry, static private in attribute called instance. This will be type database connection, right? And database connection, and this is gonna have the variable name is gonna be instance. Okay. Now we have created a attribute, right? Now what we're gonna do, simply, right? We're gonna check if instance is null. We're gonna check. If it is null, what we're gonna do is we're gonna set instance to be a new database connection object, right? So what are we doing here? We have made the constructor private, right? We have made the constructor private over here, but this constructor can be called inside the class, right? So the control has come inside the class, right? Since we have made it private, from outside I cannot call it, right? But from inside the class I can call it, and I'm calling it under get instance method, right? So that gives us the control on creating the instance of this class, right? Else I can just return, not even else, right? Else is not required. I can return instance. Perfect. Now we have created the instance of this class, right? So now what's gonna happen? Class A, if it has to create an object of this class, it cannot directly call new database connection, right? This would be wrong. What does it have to do? Class A has to call database connection dot get instance and then store it in the variable of type get database connection, right? So it has instance. Now class B will again do the same thing, right? Now the instance has been created by from class A, right? It has been created when class A had called it, right? Now for class B, this instance won't be null, right? This particular instance won't be null, right? So what will happen? It will return the instance that was created, right? So what is this assuring? This is assuring us that Same instance of the object is being used across the entire system, right? Perfect. Perfect. This is what singleton is. This is actually what singleton is. Okay, this is all singleton is. Okay, now let us do that in our code base. Okay, so I'm currently at v1. Okay, v1, what am I going to do? I will actually call this database connection itself, right? Database connection. Okay, here, what will I do? Right, I will make my this thing private database connection. No, database connection. Right, this is private now. Okay, now I will have a method public static why we using static? So that it's accessible without creating the object of the class. Get instance, right? This get instance method, what it'll do is, why am I getting an, what if it's static not allowed here? I think okay, yeah. Right. So this will be public, and the type of this, the written type of this will be database connection, right? Now what we'll do is, right, here we'll have a attribute, right? Let's call that private static database connection instance, right? Perfect. Now what are we going to do? Check if instance equals to null, right? If it is null, what am I going to do? Instance equals to new database connection, new database connection, and here I'm going to return instance, right? Here I'm going to return the instance. Perfect. Okay, now we have this, and yeah, now what's gonna happen? v2, I'm gonna create another class. I'm gonna call it class A. Let it be just A, right? Here, what do I want? I want to do I name it class A, or do I, no, actually not required. Let me delete this. Right, this is not required. What I'll do is I'll just put the client and put it here, default, right? Under client, right? Under client, what am I going to do? I'm going to create a connection of class A, right? Now let's just see, right? Database connection obj1 equals to new database connection, right? When I do this, it's gonna throw us an error. Why is it throwing us an error? Because it is private. Database connection has a private access in Singleton v1 database connection, right? So this is private, so I cannot do this, right? So what do I have to do? I have to call the get instance method. So I'm going to have to call the database connection dot get instance. Okay, perfect. Now when I do database connection object2 obj2, right? obj2 equals to get database connection dot get instance. Let's see what happens, right? Ideally what should happen is data object2, since the since the instance is not null, it should return the same object, right? Let's see if that happens. Okay, I'm going to set a debug pointer here. I'm going to set a debug pointer here and here. Okay, let us try to debug this. Okay, Now let us actually go to yeah, let's go to this one. See, instance is null, yes, so it'll have to go in, right? Okay, so now it has set the instance, right? It's going to return that instance, right? So now if you see, database connection dot get instance has returned us database connection instance 492. Perfect. Okay, let me go here, right? Now let me go again, right? It'll check if instance is null. Instance is not null, it's false, so we'll return the uh, so yeah, it was false, right? So it will just return, it'll just yeah, let me debug only this, right? If instance is null, right, it's not null, right? So initially it is null, right? This is the first time it's coming in, so it's going to set. Now it has come to the second time, right? Instance is null, no, false, so it's not going to go into this if condition, it's just going to come out and return that instance, right? Now if I go here, yeah, yeah, perfect, right? Now you saw that, right? So object 2, the instance of object 2, right, and object 1 is the same thing, right? There's just one instance created and both of them are using it, both of them are sharing it, right? Perfect. So now this is what your singleton is, right? Perfect, right? Well and good. Now so yeah, ideally this is what your singleton pattern is, right? So whatever the problem that was there, that was creating multiple objects of the same class, we have solved it by giving the control to the class itself, right, and creating only one instance, right? Now now if you remember in the starting when I told you, it is not just about creating singleton, right? There's so many things to it. Now we'll get to that then. Okay, now if you guys know the concept of multi-threading, right? What is multi-threading? It is when different process, right, run concurrently, right? So in a system, right, where you have let's say a CPU with two processors, right, dual core, right, and each processor can process approx about two threads at a time, right? So uh, dual core can process about four threads, right? Now let's say that you have created four different functionalities, right? each of them are running on each of them are running on different threads, right? Now I will make a video on that, but ideally what happens is the first thread will go in. It's not that the first thread will complete it, only then the second thread will go into the CPU. What will happen is the first thread will go in, right? After some time, right? After processing for some time, what will happen is there's a there's a concept called as context switching, right? So what does your CPU do? It switches to another thread, to another process, right? That is how when you see in threading, right? One, like let's say that you have two things, right? A plus what you're doing is you're doing uh, you know two things, like two functionalities, a plus b and a minus b, and both of them are running on different threads, right? This is running on thread 1, this is running on thread 2, and you written a plus b first, then a minus b, right? And you put this on two different threads. Now this can finish before this, or this can finish before this, right? Because both the threads are running, and whatever finishes first by the CPU will get finished first, right? So it doesn't mean that it is running sequentially only after this particular code this code will run. No, since it's running on different thread, because of context switching, what happens is ideally anything can happen, anything can finish before anything, right? I will make a video, extensive video on multi-threading, but for now this is what ideally happens in the background. This is what the CPU does, right? but then a lot of things into it, right? You have process, under process you have so many things, right? How the state is stored, how does context switching happen. I will make a video on all that, right? But for now, this is what multi-threading is. Now, let us say that, right? Just for this point of explanation, right? Let us say that your system has 10 threads running, okay? All the threads need this particular object, need this particular instance, okay? Now, what will happen? You so whatever you've done over here, right? You'll do it across all the threads, right? All the 10 threads, right? Now, what will happen? Right? Now, what will happen? All the 10 threads will come to this particular point, right? Initially. Now, when it comes over here, initially when it comes over here, for all the 10 threads, the instance is null, right? For all the 10 threads, remember it's not running sequentially, right? It's ideally not parallelly. Let's call it parallel, okay? It's not running sequentially, right? So all the threads will come here. For all the threads, initially instance will be null, right? Instance will be null. Now what will happen? When the instance is null across all the threads will go in, right? It's not running sequentially, right? So for all the threads it's null. Since for all the threads which is coming here it's null, it is going in, right? So ideally what will happen? What will happen? 10 new database connections will be created, right? 10 new database connections will be created. Now, this defeats the purpose of even using a singleton, right? What is the point of singleton? Only one instance has to be there. But if all the 10 threads come in and they will create a new object, right? They will create a new object. When they create a new object, when this will ideally create a new object in the memory, right? This will ideally create a new object in the memory, right? So this will create new objects in the memory. This will create 10 new objects in the memory, right? Which defeats the purpose. Now this is an issue we have to solve. Okay. So this is where we get into it, right? Now this is an issue we'll have to solve, right? Let's think about how we can solve this. What can we do? Okay. Let's go through each of the solution, right? Now, what are we doing? Right. Now, what are we doing? In singleton, okay, let's go through each of the solution. Let's go through solution 1. Solution 1. Okay. What is solution 1? What are we doing? When we come over here, we are checking if this particular instance is null, right? If it is null, we are creating the instance, right? So you might be like, hey Siddharth, why do we even need this piece of code? Why do we even need this piece of code? Right? Why do we even need this piece of code? Right? Okay, before we enter that, there is a concept called as a critical section, right? What is a critical section? A critical section is something, right? A section of a code. A critical section is nothing but a section of a code which is at a thread risk, right? What do I mean by thread risk? Just as the example that we discussed, right? Multiple threads can come in, right? It's not thread safe, right? Multiple instances can come in. Why? Because you're using a shared resource, right? We're using a shared resource. For all the 10 threads, this instance is common, right? Since we're using a shared resource, this thread safety issue comes into picture, right? So what happens? This particular thing becomes a critical section, this particular thing becomes a critical section. Okay, now let me mark it better. Okay, this becomes a critical section. Okay, let's come back to this. Okay, now you'll be like, hey Siddharth, why are we even checking? Why are we even checking? Right? We can do something different, right? What can we do? We can say that instead of checking, right? And write it out here. Solution, solution one, right? Instead of checking, what we can do is, instead of this entire if condition, what I can do is, I can just say new database connection, right? Right? So this whole condition is not required for me anymore, right? This whole condition is not required for me anymore. All I can do is, under the get instance method, I can return this instance, right? So this instance will always have the object. It'll have one object, right? It'll have one object, right? But it'll always have the object. It'll have one object. So it will always return that object, right? So I don't even have to worry, right? Now it's thread safe, right? Because why? Because let's say 10 threads come in here, all the 10 threads will have the same object, right? Because why? Because object is already created, right? So I can just return that, right? So this solves the purpose, right? It makes sense. This solves the purpose. So now what is this called as? What are we doing here? We are checking if instance is not there, then we are initializing the object, right? What is this called as? If it's not there, we initialize it, right? If it's not there, we initializing. Simply we're not initializing. If it's not there, we initialize it. What is this called as? This is called as lazy execution, right? This is called as lazy execution. Why? Because it is saying, hey, if it's not there, I'll do it. I'm simply not gonna create it for you. Okay? This is called lazy execution. Okay. Now you have removed the approach of lazy execution. Now what you've done is, in the start itself, not during the runtime, during the compile time itself, you are creating an object of this class. Right? Even before anywhere it's called, if it's called or not also, you're creating this object. Right? So this instance will always have this object. Right? This is called as eager loading, eager execution actually. Right? So what are you doing? During the start of the application itself, you're creating the object and you're leaving it. Right? Now what will happen is, if any class wants to initialize this object, anyways you have it, you'll just return that. Right? This is called as eager execution. Now, what are the disadvantages of this? What are the disadvantages of this? The first disadvantage, for the classes which don't need this, which doesn't even care about database connection, right? It doesn't make sense, right, to create an object of this. I mean, you're creating an object, it is using memory, right? Doesn't make sense for the classes which doesn't even care about database connection. No. Why? Because I don't even care about it. I don't even care if object is created or not. I don't even want the object. Why are you creating the object unnecessarily, right? Probably 2 classes need it. You're doing it for that. But there are 100 other classes which don't even need it. Why are you doing it? Right? So that is the first disadvantage. What is the second disadvantage? Okay. Second disadvantage can be, hey, I need so to initialize this particular object, I want to initialize it with a parameter, right? I want to initialize it with a parameter. Over here, get instance, you can give the parameter, whatever it is. You can give anything, right? If you want an ID or something like that, and then you can have ID over here, right? You can have another ETTR ID. You can set this dot ID equals to ID, right? Here you can here in this case you can give this id, right? Here you can receive id, you can set the id in this particular method, right? But if you're doing eager execution, how will you set the parameter? How will you set it? Because during the start of the application itself, you're creating this, right? So you're creating this, right? It doesn't have the context of what the id is, because the user has to pass the id to create the object, right? But it doesn't even have the context of id, right? So because it is just creating it during the start of the application, right? So you with if you have parameters, you cannot use this, right? When you want to instantiate it with the parameter, though the parameter is supposed to be common across all the classes that's instantiating it. Now uh, you cannot instantiate it with a parameter, right? Why? Because this is happening during start of the application. Since that is happening, it doesn't have the context of what the parameter is, and then I can't even do it. I'll throw you an error, right? So that is the second disadvantage. Okay. Now, solution one did give us a solution to resolve the issue of race condition, or resolve the issue of thread safety, but it gave us another issue, right? So this is not an optimized solution. So optimized solution one is eager execution. What is solution two? Okay, in solution two, what am I gonna do? What I do, I will set a lock. Yeah. I would suggest you to read what is a synchronized method or synchronized block. Okay, what I'll just tell you in layman terms what it is. Right? It's nothing but when there are multiple threads entering, right? What it does, it'll let one thread enter, right? Once it has processed, it'll let another thread enter, right? That is ideally what it is, right? So you can either make a method synchronized, right? I can give a keyword synchronized, or I can make this block synchronized. I can make a block of code synchronized, right? So this will make sure that all the threads don't come in, right? All the threads don't come in. One thread comes in, it gets a lock, it gets processed, gets unlocked, the second thread comes in, right? Now, does this solve the, now when I make, let's say that I'm making the method synchronized. Now, does this solve the issue? Yes, this solves the issue. Perfectly fine. This is gonna solve the issue for us. Okay, good. Now, let's think about it. Let's say that there are 1,000 threads. Right? There are 1,000 threads. Okay. Out of 1,000 threads, let's say that there's a bar. Okay. These are first 10 threads. Then you have 1,000 threads. Okay. Now, we are here. We are only talking about the first 10 threads, right? Ideally, 1,000 threads is very hypothetical, because your CPU cannot do that. But I mean, parallelly, I'm saying, right? But let's just say that there are 1,000 threads that is coming after the 10 threads. Now, the issue exists only for the first 10 threads, because the first 10 threads are the ones that are coming in initially, and for them is the one which is where the instance is null, right? 1,000 threads will come later. 1,000 threads will come later. Now, for these 10 threads, we are making this method synchronized, right? Okay, it'll go one by one, one by one, one by one, right? Now, after the 10 threads, when the 1,000 threads are coming in, over here, right? Since we made it synchronous, right? All of them will wait, right? One has to get processed. only then the other one will go, right? For one to get processed, we are making 999 threads wait, right? Because why? Because it's synchronized, right? Those instances will be created, it'll go to return statement. What I'm trying to say is, it we're making it synchronous, right? Which means that it is locking, unlocking, locking, unlocking. So what is happening? 1,000 threads are ideally, they are getting affected, right? So this will reduce the performance, right? This will affect the performance, right? For solving it for the first 10 threads, you are affecting the performance of the next 1,000 threads. Okay, right? So making it synchronized, making the function synchronized is not gonna work, right? I mean, it is gonna work, but it's not effective, right? So solution 2 was, that we had was, make method synchronized, right? You can make the block synchronized also, but again, what do we discuss? This is the critical, this is the critical, sorry, this is the uh, critical section, right? So if you make the block synchronized also, every 1,000 thread has to wait, right? Every 1,000 thread has to wait, right? Okay, now it doesn't make sense. Now what can we do? What can we do? Let's think about it. Let's come to the final solution, right? I will write the solution first, then explain it. Final solution. Our idea is correct, it's just that the way we need to structure it. Let me copy this. Yeah, let me copy this. Let me copy this. Perfect. Now, what am I gonna do? If instance is null, right? If instance is null, right? What I will do is, I will lock it. If instance is null, what I'll do is, I will lock it. By lock, what I mean is, I mean, look through that concept. Locking is nothing but you're locking a thread, right? And then after this thing, you're unlocking it. Right? What I'll do is, if instance is null, I'll lock. Okay. Now, again I'll check. Again I'll check. If instance is null, again I'm checking if instance is null. Right? I will unlock here. So the problem was a bit tricky, but look at how simple the solution is, right? This is something called as dual locking, dual, not locking, dual. I forgot the term. It's called as dual, dual locking. Let me just look into it. It's called as yeah. Yeah, it's called as double check locking, right? The term is called as double check locking. Sorry, double check locking. Okay. What are we doing here? We're checking if instance is null, right? If instance is null, we are locking it. Right? Now what's going to happen? Let's say that first 10 threads come in. Right? For all of them, instance is null. Right? So all the 10 threads will come and enter over here. Okay? Now I'm locking. When I'm locking, only one thread will come inside. Right? Now what will happen? I'll check if instance is null again. Okay, instance is null. It will create that instance, right? It will unlock and it'll return that instance. Right? Now the second thread will come in. It will check if instance is null. Now instance is not null. Right? Instance is not null. So it'll directly come to this return condition. It will directly come to this return condition and return. Third one will come in. It'll check if it's null. No. Directly come out, return. Okay. First thread, 10 threads are solved now. The other 1000 threads which are coming in. Right? It will come in. All the 1000 threads will come in. All 1000 come in. Now, is the instance null for them? For every one of them, is the instance null? No. Instance is not null. Right? Instance is not null. So they won't even come in. The next 1000 threads which come in over here, for them, instance is not null. So it'll work as expected, as regularly it's supposed to work. How it's supposed to work, it'll work like that. Why? Because your instance is not null. For the next 1000 which are coming in, your instance is not null. So it will directly come here and return. Right. So this is exactly how we handle the multi-threading issue that we have. This is called as double checking lock. We are double checking over here. If instance is null, we're locking. If again we're checking if instance is null, and then we're unlocking and return. Okay. Perfect. I hope you understood this. Let me show you the code example for that. Right. What they've done here is they've probably done it in a bit different way, right? And ideally, how are we locking, unlocking? You can use a synchronized block, right? You can use a synchronized block. So again, see, they're checking if result is not null, then you're returning the result, right? Again, right? Again, what happens is you have a synchronized block where you're locking it. Again, you're checking if instance is null, right? If instance is null, if it's null, you're returning. I mean, if it's null, you're creating, and then you're returning. If it's not null, you just return. Right? So this is exactly how we solve the multi-threading issue. Right? The reason I don't want to show you the code is ideally it's the same code, right? Whatever that I wrote over here and whatever that I showed you over here is the same code, right? And this is how you can create the threads, right? You create the thread, right? And then you give thread dot start, right? You start the thread, right? And then it's gonna come in. Okay, this is something that you need to read, right? Because you need to implement runnable for you to start the thread, right? Right. So yeah, but yeah, this is something that's out of this context, right? But yeah, this is how you start a thread, and over here, you're using the this thing. You're running it, right? And then you're giving get instance path, right? It's gonna come here, right? And then the dual checking lock, dual checking locking will happen, right? And then it'll return the other one. It's the same code even if I do it, right? So it doesn't make sense for me to show it to you. Right? Perfect. But I did show you how the actual singleton is, right? I hope you understood this. This is all about singleton. I will come to the applications of it when I go through the when I pick up a case study and I try to resolve it, right? But this is how what a singleton pattern is, and I really hope you understood it. I really hope you understood where we can apply it and why do we need it and where and all it can be applied, right? And yeah, I hope you had fun. Thank you.